Welcome to Rani Chemistry classes. In this video, I am going to discuss about the 2 marks questions in intermediate first year chemistry 4th chapter chemical bonding and molecular structure. For intermediate public examination 2 marks questions 2 are coming from this chapter. So the first one is draw the Lewis structures for the NF3 molecule. In NF3, nitrogen belongs to fifth group. It contains 5 valency electrons. 5 valency electron. Fluorine belongs to seventh group. It contains 7 valency electrons. So, 1 nitrogen is present and fluorines are 3. So, 7 3s are 21 plus 5. So, total 26 electrons are there. Total 26 electrons are there. So, each nitrogen forms 3 single bonds with 3 fluorine atoms. First you have to write. Nitrogen contains 5 valence electrons. 1, 2, 3. So remaining 2 electrons are written on that is the lone pair which are not involved in bond formation. Fluorine contains 7 electrons. The 7th electron and nitrogen of 1 electron form here bond. So 7 electrons, 1 electron is involved in bond formation. Remaining 6 electrons, 1, 2, 3, 4, 5, 6. Here also fluorine contains 7 valence electrons, 1 electron is involved here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now each atom is attains octet configuration. Here 6 bond means 2 electrons, that is 1 electron from fluorine and 1 electron from nitrogen. So fluorine attains, that is octet configuration. Here fluorine attains octet configuration. Here fluorine attains octet configuration. Here nitrogen contains octet configuration. 2, 2, 4, 6, 8, 6 plus 2, 8. So here each atom attains the octet configuration, that is by mutual sharing of electrons. Okay. Here, so total electrons involved in bond formation are 26. So this structure was proposed by Lewis. So this is the Lewis structure for NF3 molecule. Next, second one, BF3 molecule is trigonal planar but NF3 is pyramidal. Why? Here, according to the Vesper theory, boron BF3, boron belongs to third group. 1, 2, 3. 3 electrons of boron forms 3 sigma bonds with 3 fluorine atoms. Okay, here bond pair of electrons are 3 bond pair of electrons, 0 lone pair of electrons, total bonds are 3. 3 means it undergoes, that is sp2 hybridization. It undergo sp2 hybridization. Similarly, NF3, nitrogen belongs to fifth group. It contains 5 valence electrons. 1, 2, 3, 4, 5. 3 electrons of nitrogen form 3 sigma bonds with fluorine. Here NF3 contains 3 bond pair of electrons plus 1 lone pair of electrons. Total 4. 4 means sp3 hybridization. sp3 hybridization with 1 lone pair means pyramidal shape. It has trigonal pyramidal shape. Here BF3 has symmetrical structure. Symmetrical means which contains only bond pair of electrons without lone pair of electrons are symmetrical molecules. So here BF3 contains only 3 bond pair of electrons. So it is symmetrical and it undergoes sp2 hybridization. Its structure is trigonal planar structure with no lone pair of electrons. While NF3 has trigonal pyramidal structure because it undergoes sp3 hybridization with 3 bond pair and 1 lone pair. Its structure is trigonal pyramidal which contains lone pair of electrons. Due to lone pair and bond pair electron repulsions, here the geometry is changed. Okay. Next, third one, O2 is paramagnetic while O2 minus 2 is diamagnetic. Why? O2 is paramagnetic means according to the molecular orbital theory, O2 contains total electrons are 16 electrons. Its electronic configuration is sigma 1s2, sigma star 1s2 molecular orbital configuration. sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px equal to pi 2py, pi star 2px equal to pi star 2py. Here 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16. Okay. So according to molecular orbital theory, two unpaired electrons are present in anti-bonding, that is 2p orbital. Anti-bonding 2p orbital. So it is paramagnetic because it contains unpaired electron. Whereas in the case of O2 minus 2, O2 minus 2, the same configuration comes, but here pi star 2px equal to pi star 2py. Here 2 electrons. Here no unpaired electrons in the case of O2 minus 2 because here total electrons are 18 electrons. Minus 2 means it gains 2 electrons. 16 plus 2, 18 electrons. So it does not contain unpaired electrons. That means it contains paired electrons only. So it is diamagnetic. Next, fourth one. NF bond is more polar than NH bond, but NH3 is more polar than NF3. Why? In the case of NH3 molecule, compared to the hydrogen, nitrogen is more electronegative. Nitrogen is more electronegative. So this is the structure of NH3. Here nitrogen it contains 3 bond pair of electrons and 1 lone pair is there. Here the lone pair means that is atomic dipole is in this direction. Here nitrogen and hydrogen. Nitrogen is more electronegative, so the electrons are moving towards the nitrogen. All are here the bond dipole. This is the bond dipole and lone pair dipole, that is atomic dipole, are in the same direction. So net dipole moment is more. But in the case of NF3 molecule, compared to the nitrogen, fluorine is more electronegative. Fluorine is more electronegative. So the electrons are moving towards the fluorine atom. So here the bond dipole is in this direction and atomic dipole is in opposite direction. So the resulting in less dipole moment. Hence NH3 is more polar than NF3. Next, fifth one. Water is liquid at room temperature, but hydrogen sulfide is a gas. Give reason. In water, due to strong intermolecular hydrogen bonding, it is liquid at room temperature. Intermolecular hydrogen bond means hydrogen bond formed between the hydrogen atom of one molecule and the oxygen atom of another water molecule. Intermolecular hydrogen bonding exists, that is between the two molecules of same or different. Okay, so water undergoes intermolecular hydrogen bonding. So due to presence of this bond, it is liquid, whereas in H2S such type of bond is absent, so it exists as a gas. Okay, next, sixth one. Write the bond order and magnetic behavior of H2. So according to the molecular orbital theory, the electronic configuration of H2 molecule is H2 contains 2 electrons because each hydrogen contains 1 electron. H2 molecule means 1 plus 1, 2 electrons. So its molecular orbital configuration is sigma 1s2, sigma star 1s0. So bond order equal to number of bonding electrons minus anti-bonding electrons by 2. Here bonding electrons are 2, anti-bonding electrons are 0. So 2 by 2 means 1. That means in between the two hydrogen atoms, single bond is present and it does not contain any unpaired electrons. No unpaired electrons are present, so it is diamagnetic. Next, seventh one. What is hybridization? The phenomenon of intermixing of suitable atomic orbitals of an atom resulting in the formation of new set of orbitals of equivalent energies and shape is known as, this is hybridization. The number of hybrid orbitals formed are equal to the sum of the atomic orbitals combined. So they are having same energy and shape. Next, state octet rule. Octet rule means every atom must possess 8 electrons in its outermost energy level for its stability. So having 8 electrons, it is more stable. Next, What is meant by bond order? So bond order means number of bonding electrons minus anti-bonding electrons by 2. It is defined as 1/2 of the difference between the number of electrons present in the bonding and the anti-bonding orbitals. So this is bond order equal to number of bonding electrons minus anti-bonding electrons by 2. So give two examples of odd electron molecules. So odd electron molecules are NO, NO2, ClO2. Here nitrogen is 5 electrons. Nitrogen and chlorine species, they are fifth group, 5 valence electron, chlorine 7 valence electrons. So they must contain the odd electron. So for example, NO2, ClO2. Here nitrogen contains 5 and oxygen contains 8. So total odd number of electrons. Nitrogen contains 5, oxygen contains 8 plus 8. Here chlorine 7, 8 plus 8. So they are containing the odd number of electrons. Like and subscribe this video. Thank you.